They call it the Snow Canyon. I don't know exactly how they flower this thing.
Why are the trees? Oh, it's the top.
I was just thinking that looked like Mario.
I figured it out.
It's around Honshu in Japan. They have 1927, a depth of 465.4 inches on Mount Ibuki at 5,000 feet. They call them the Japanese Alps. Did you know there were Japanese Alps?
No.
Because there's not.
There are.
You haven't heard?
No. Now, Glenn, wrap up plate tectonics. So if you didn't bring anything today, you just sit back and watch during this part. If you did, I want you to add a few little notes to your notes. Then make ice cream and eat ice cream, clean up ice cream. If you want to stick your hands in the slush that we'll have left over when we pour all the salt and ice into a bucket, don't leave your hand in there for over 20 seconds.
Why?
Because you may get frostbite. I don't want to get frostbite. And make proper snowflakes. I think I skipped over number 6, but I'll come back to that. When it's time to make snowflakes. So, if you have your notes here, get them out. I want to have you add a few things onto them. Then I'm going to give you a short practice test, and then we'll do the ice cream. What?
Is there a refrigerator where I can put this in?
It is. It's going to be fun. This part's going to be fun. But it's going to be really fun.
I didn't bring a pencil.
Just open up the window and set it on a. Is there a little sill out there that you can set it on? Just set it on the ground. We could dangle it from a string too. We're just going to get some buckets.
Wait, I have a question.
Okay. Now, a few things I want you to add. Is it out of focus there? Is that the problem?
No, it's good. I was just wondering why we're having a practice test.
Because I want to bring closure to the stuff we've been doing in a few days, the last few days before we leave and break.
I also didn't bring a pencil.
Oh, I like it open.
Take off your jacket.
I didn't bring a pencil or a pen.
It's okay. We'll find something. So, a few things to add to this. This kind of a plate boundary, letter A. By the way, I've scanned all these. These are on my website. If you have bad notes or notes that are worse than mine, you can just print these out. I've added a couple of things. When you have two continents colliding, hitting one another, you get earthquakes where they're colliding. But you don't. You get every kind of earthquake except for deep earthquakes. You only get deep earthquakes, deep focus quakes where there's one plate going under the other. So somewhere on this diagram, make a note that there are earthquakes as these two plates smush into one another. You get shallow ones and you get intermediate ones, but you don't get any deep ones.
You look funny on this picture.
That's okay. I'm fine with looking funny.
Do you know why that happens?
The cameras are. Turn the music off.
What's your problem, man?
B. Make sure that. I think I have a laser pointer in here somewhere. What? Yeah, I very rarely use it, but I like to laser point. So if you haven't labeled the Andes Mountains, this is ocean crust, continental crust. The ocean crust goes underneath the continental crust. Make sure that you've labeled those Andes Mountains, just because that's the example I want you to be familiar with. And if you haven't made the notes, this kind of volcano, just looking at it, what kind of magma do you see in it?
Hot magma.
Both kinds. Now, if it was just mafic, it would ooze, it would settle down, it would never really pile up because it's runny. But because it's got the gooey felsic stuff in there, that allows it to be steep. And it also allows it to have explosions. This right up in the top, if that gets plugged up with the gooey stuff, pressure can build up until boom, it explodes. So somewhere on your diagram, note that this is steep, or just be able to tell from your picture it's steep. And also note that it can have gentle or explosive eruptions. Sometimes the mafic stuff oozes out. Sometimes the felsic stuff plugs it up, and you get explosions. Now, with regard to earthquakes, the important thing about this kind of a boundary is that you can have shallow ones as this stuff burns its way up and the magma burps its way up through the volcano. You can have shallow focus quakes. You can also have deep focus quakes. You can have earthquakes of any depth at these boundaries. One last thing, the name for this, when one plate dives under another, it's called a subduction zone. That's something to be familiar with. I think that's about all that I didn't say the first time. Maybe I did say some of that, but didn't write it. What? No. Just moving through these. I added a few things to these notes, and I want to make sure that I point them out to you. The C was the transform fault, and if I didn't note it earlier, right along the transform fault, you have shallow focus quakes. There's nothing diving deep down and under anything else, so that's about all you have here. There's no magma that comes up, no volcano forms, just the plates shear across one another. You get shallow focus quakes. And if you didn't put San Andreas Fault on there somewhere, or at least California, write that on there.
I hope you know we're gonna fail this practice test.
Doesn't matter. That's why it's practice.
Well, yeah,
But if I thought you wouldn't fail it, I'd just go ahead and give you the test.
Okay.
Now, ocean convergent. This is like the one I showed you a couple of boundaries before, except that here we've got an ocean plate on top and an ocean plate down below. And you should have this drawing pretty much. Everything is exactly the same, feature-wise, except there's no continent here. So this is also called the subduction zone. There are deep focus quakes. There are shallow focus quakes. This volcano. Good. Can you be still and quiet? These different colors in here are just showing that you can get mafic magma. You can have felsic magma. The volcano can be explosive. If the felsic stuff plugs it up, it can be gentle if the mafic stuff just kind of oozes out. And if you didn't write it, I put an asterisk on all these where I listed the example from the real world where you find this. This is like Japanese islands. Ocean divergent. I don't think I said anything about quakes the first time, but at all of these things we're drawing, you can have shallow focus earthquakes. If it's a transform fault, it's from scraping. Anytime you have magma coming up, volcanic eruptions, that can cause earthquakes. Volcanoes are just shaking all the time. Not necessarily when they're erupting, but when this magma is coming up down below, it kind of burps its way up to the top. So, but there's nothing diving deep, so these are just shallow focus quakes. And I think that's about all I added to that. I put the asterisk there, just to note that this is like the Mid-Atlantic Ridge. This would be North America, this would be Africa or Europe. The ocean hotspot, I added some dots in here to show that there could be shallow focus quakes. Just as this magma burns its way up through here, shakes the volcanoes, you can get earthquakes in Hawaii, but not deep focus. I think that's all. I added the note that this was mafic material, but you probably don't need that note. It's pretty clear that it comes from down here, and these volcanoes are all dark.
What's
So-
mafic again?
So
How do we determine whether it's shallow or deep earthquakes?
the only time you'll ever have a deep focus earthquake is at a subduction zone like this. If one plate dives down into the mantle, that's the only thing that can cause deep focus earthquakes.
Okay.
And the only time you'll get that is with ocean convergent or ocean continent convergent.
All right.
Continent divergent, this pretty much has the same features as ocean divergent, except it's happening on a continent. And you can have shallow focus earthquakes right around here. If you didn't write it down, I think I wrote Africa, East Africa. This is the African Rift Valley that's forming right in between as Africa is starting to split apart. So, 11:42, what time's class get out?
Soon, so we better go quick.
47. I think we got enough. Maybe this would be a good thing to do next time.
Yes.
Yeah. So the next thing we're gonna do,
Quick.
That's actually what I was thinking.
you wanna do it now?
No. He can do it now. We'll eat ice cream.
I'll give it to you, Keegan.
Okay.
And you can just do it whenever you want. Does anybody want it now and you can have it done before we come back?
I do.
I'll just do that then. I'll just look at it.
I don't care when you do it, but there'll be some class time to do this when we get back. It's just practice, yeah. This is just a little nice review how much of this you have internalized. Anybody else want one?
Now let's eat ice cream.
All right.
Ice cream.
And if you change your mind, there's a link to this on my website. You can print this out on your own.
So I think we're done, right? With the
Now, there's a password. You're going to have to know this password.
password.
It's a very long password.
Password.
Why is it so long?
Because you have to work for your ice cream.
What?
No, don't move me. All right. This is the password right here. I want you to be able to explain why this process works. So this is salt. There's sodium, which has a positive charge, and chlorine, which has a negative charge. There might be some other kinds of salt mixed in with this. Those stick together. This is called what kind? First of all, is it a compound?
Yes.
Yes, because it's two different kinds of things. Is it a molecule?
Yes.
No, because there's no sharing of electrons. This is an ionic compound. Positive and negative kind of magnetically stick together. So over here, this is, tell me what this is supposed to show. What's that?
Molecule.
Yeah, these are supposed to be, the dark ones, these are hydrogen, and the light ones, those are oxygen. So this is a water molecule, this is another water molecule, this is another water molecule, and I better do this before my diagram just doesn't work out right. So 6 water molecules, is this a solid, liquid, or gas?
Gas.
It's a solid. And when water molecules freeze, they come together in this shape. And I could continue this pattern, draw something else over here, if I again do it right. These hydrogens, these are positive. The oxygen has a little bit of a negative charge. So the positives stick to the negatives like this. And that's why water goes into the shape. Now, this one's missing a leg. That would probably go out of the picture to connect to another. Well, I guess I can connect that. I'll just do this one like this. So just note that one's missing a leg. That would have to come out of the picture or something. But this is like ice when you freeze water. That's why you get those kinds of cool looking crystals up here. That's why all the geometries are hexagonal. And why when you're folding your paper and you're trying to do those and you get octagons, you've done it wrong because you should have hexagons. So here's how the salt, the whole process works. I'm going to walk around with a cream mixture in a little while, and you can't get any cream unless you or your partner can tell me how this process works. And here's how it works. You've got, it's basically restate this for me. You can say the first part 2 ways. You can either say a sodium ion comes in and grabs an oxygen molecule, or you can say a chlorine ion comes in and grabs a hydrogen. So this negative likes that positive, this positive likes that negative. That's the first part. So the first part is sodium ion grabs an oxygen. The second part is these salt ions break the hexagons apart. And they do that because they come in and they grab them. They're all trying to hold hands, and the salt's coming in and taking the hands and pulling them away, and they can't hold hands like this. The salt's doing that. So first part, sodium ion grabs an oxygen atom, and it starts to pull the hexagons apart, thus melting the ice. Ice needs what in order to melt? Heat. I don't really care if you say latent heat of fusion, but as long as you say heat, it's okay. So this is forcing this to melt by grabbing onto the oxygens or grabbing the hydrogens. Melting requires heat. Where does the heat come from?
Energy.
cream?
The cream. It takes the heat from the surroundings. One of the surroundings is the cream, so the cream gets cold. The other part of the surroundings is going to be your hands, so your hands are going to get really cold. Now, you can think about that for a little while. Point the camera over here.
Okay.
Here's what you're going to need. You're going to be doing this in pairs. You're going to get one large quart bag. Actually, you'll get 2 quart bags. And you're going to have a cup and 2 spoons. Okay. So, and some ice. Oh, no, snow. This is snow. It's not.
Where are you gonna get the snow?
And you'll also get some salt. And the salt, I've got a little metal cup. Just fill this little metal cup up to about half full. So, don't listen to him. So what you're going to do is get one of these baggies, and I'm going to come around with some cream, and you have to explain to me this process of how making ice cream works. When you've done that, I'll pour cream in one of these containers. There's your cream. Then you seal this very, very, very carefully. Try to get the air out. Seal it carefully. If you're not good at sealing Ziploc bags, have somebody else do it for you, because if anything other than cream gets into this inner bag, it's just going to be nasty and ruined and won't work. You've ruined your experience. Then in the other one, you'll put this bag into the other bag. So this bag goes in here, and then you surround it with snow. And like shut it. And then you start to mix it. Oh, and salt. And then you start to mix it together. And when you put the snow and the salt together, what happens?
Tries to melt.
The salt melts the snow because the sodium ions and the chlorine ions go in, and you can just say they grab the water molecules and they pull them out of their hexagons, and that causes it to melt. But melting requires energy, and it's going to start sucking energy out of everything around it, including the cream and your hands. It's going to get really cold. You want to trade this off. So then you just kind of mix and mix and mix. Mix the snow with the salt as well as you can. You want to see the snow melting. If it's not melting, this isn't going to be working. The melting is what makes it all happen. When you get air bubbles in your bag, open up your outer bag, squeeze the air out, do some more squeezing, get some more snow if you want. After a while, you're going to notice that your ice cream is frozen, your hands are really cold. And at that point, take your inner bag out. One person, you can scoop with a spoon into this extra cup. One person can eat from the cup. One person can eat from the bag. Although, if I've got extra cups, if you both want a cup, that's fine. But there are enough spoons and cups, so you don't have to share one another's spit. Yeah, eat it.
You said on this test, which letter identifies the type of features that makes, that created the large volcanoes in our area? Do you mean in Seattle?
No, yeah, sorry, that was old from then.
Okay.
There. Yeah, just cross that one out. We don't have any large volcanoes here, in case you haven't noticed. All right. So I'll bring some materials out. I'm gonna need people to go out and get snow. On it.
Got it.
Alright, I'll head over to the rink. Well, I don't care about my neighbors.
It doesn't matter if the snow is. Do not eat the snow.
Is this still on? Oh, it's still on.
It's still on. Let's make a movie. No, don't. Let's make a movie.
Now, if you go out the front,
Movie.
This is the most fun class ever.
This movie is called Keegan's Face.
pack it into
Here is Keegan's face in action.
All right. Each group.
Go, Keegan.
Say each Ziploc bag. So
That's amazing.
I'll just leave the materials here. Get Ziploc bags. Get yourself a cup. Get yourself a spoon.
Wait. No.
Wait, open it.
No, open it.
Ice cream.
No.
No, I'm I'm the director.
Wait,
I'm the director. No.
Gotta put it, William.
okay, there's too many people on this camera.
Hey, William.
Hey!
Tegan's face, not William's face.
I want to see Tegan's face.
Yeah.
And by the way, if you want this recipe, it's just half and half. Mix
No.
a bunch of sugar and some vanilla.
Ooh, ice cream.
Alright, stop. That's boring. It's just like blackness.
Okay.
Wait, we actually have to make it?
Okay.
Ice cream.
Ice cream? Did someone say ice cream? Stop, you ruined it. It was gonna be dramatic and zoom in on Casey's face. Ice cream. Yeah, look out, Abe, look out! Beep, beep, beep.
Where's Carl?
All right. When you feel like you're ready to explain the process, I'm gonna stand behind you so you can't look at the screen.
How do I tighten this?
Raise your hand if you're ready for creams.
Oh.
All right. Tell me how this works.
Okay, bye-bye.
Okay. Okay.
And then breaks the right? And then melt it and use the way you
Okay.
Yeah, I'm gonna sit right here, Mr.
Open.
Stapleton.
I'm gonna pour you about 6 ounces. I know it's all bad. In fact,
No.
if you want to make more,
Done.
I know what part of
Hi, Ian.
Hello. Get that you can make more ice cream after that. You got it?
Take some more.
Okay. Right? Yep.
You should write a song about the ice cream.
Yep. There you go. They're bringing this up empty now. Very good. I've got to bring the salt in just a second. You put salt in your outer bag. Don't put it in your cream.
When did we sing the popcorn song?
Hold on. I'm going to bring the salt in.
We sang the radio.
Yeah, that's what I meant. Oh, did I say popcorn song?
Well, we were talking about it.
Is this seriously still going?
Salt. Don't mix it in your ice cream.
Don't mix it in. To
Here's a
your ice
song
cream.
called "Don't Mix It Into Your Ice Cream."
Goes like this.
Dum 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 dum. Don't
mix
put
it in
salt
to
in your ice cream.
cream.
Don't
Don't
put
do it,
acorns
'cause
in
it's
your
bad.
ice cream.
Ice
Don't
cream,
put
ice cream,
snot
ice
in
cream,
your
ice
ice cream.
cream.
Don't put hair in your ice cream.
Carl's hair. Ice cream.
Especially not Carl's.
Yeah, especially not his. Look,
Don't put that hair
it's
in
like
your
an
ice
afro.
cream. It wouldn't be very good.
It wouldn't taste good. No, it wouldn't. Put in Connor's hair though. That's okay. Okay, I'm gonna stop this.